Do you feel the vibes?
All right, so this is 8.4. Now in 8.3, we started graphing reciprocal functions. So we started talking about, horizontal asymptotes, vertical asymptotes, where the domain does or does not exist, and so on. Now we're going to expand that and start graphing rational functions in general. So a rational function is one where you have an expression in the numerator and another one in the denominator. So for example, something that looks like this. You have your f of x, but that equals g of x over h of x. And both of those are polynomial functions with no common factor. So basically, like, they don't cancel out. So to graph a rational function, we have to first look at the zeros and the asymptotes, right? That's why section 3 was so important, because it trained you to just go into the asymptotes first. All right, so let's talk about zeros. To find the zeros of the function, you have to set g of x equal to 0 and solve for x. In other words, g of x, remember, is the numerator. So you have to set the numerator equal to 0. All right, so for example, suppose we have y equals x plus 2 over x minus 3, right? So you see this is a rational function. In the numerator, you have a function, x plus 2. In the denominator, you have another function, x minus 3. To find the zeros, you ignore everything. You just look at the numerator and you say x plus 2 equal to 0, x equals negative 2. That's the 0. That's where the graph will do what when we graph it? Cross the x-axis. Good. Okay, so that's that. Now, to find vertical asymptotes, we already know this, right? Because we did it on the quiz. To find vertical asymptotes, you have to set h of x to 0 and solve for x. Basically, now you have to set the denominator equal to 0 and solve for x. So here, in that same problem, to find the vertical asymptote, you say x minus 3 is equal to 0, x equals 3, that's the vertical asymptote. Okay, the horizontal asymptote is a different story. For the horizontal asymptote, you have to compare terms from the numerator and the denominator. But which terms do you compare? You have to only choose the terms with the highest degree or the highest exponent, right? So you look at the degree of g of x. That's the numerator. If the degree of g of x is greater than the degree of h of x, then there is no horizontal asymptote. Okay. If the degree of the numerator is less than that of the denominator, then the horizontal asymptote is y equals 0. So let's look at some examples. So for example, for the first one, suppose I have y equals x squared plus 3 over x minus 1. Okay, what is the degree of the numerator? 2. What is the degree of the denominator? 1. Because it's higher degree on top, there is no horizontal asymptote. All right, now let's take another example. Y equals x squared plus 3 over x cubed minus 4. Okay, so look at the degree in the top, it's 2. Here, it's a 3. You have a higher degree in the denominator. That means the horizontal asymptote is y equals 0. Doesn't matter what these numbers are. Okay, it could be 1 higher, it could be 5 higher, it doesn't matter. It's just y equals 0. Yeah.
What if it's the same?
Okay, that's the next one. If the degree of g of x equals the degree of h of x, then the horizontal asymptote is the leading coefficient over the leading coefficient. So let's take a look at that here. So suppose, for example, you have y equals 5x squared plus 7 over 3x squared plus 5. All right. So look at this. They have the same degree, right? So the horizontal asymptote will just be the coefficient over the coefficient. So it would be y equals 5 over 3, the simplified coefficient. All right. So this is how you find horizontal asymptote, vertical asymptote, and zeros. Okay, let's compare to what we were doing in section 3. We didn't really have to find the zeros for that one, but that's easy. You know, you can do that one. This, how to find the vertical asymptote, is exactly the same, because in that one too, for the quiz, we had to set the denominator equal to 0, right? This is why I trained you guys to do that then. What's changed or modified is how to find the horizontal asymptote. So you have to compare the degree in the top, the degree in the bottom. All right? Okay, questions? Okay. So take a look at some examples of rational functions here. So take a look at this one. Do you see how there is a vertical asymptote at x equals -1 here, right? Very clearly right here. Okay, take a look at this. I have 2 vertical asymptotes here, right? At x equals -1 and at x equals 1. And then the horizontal asymptote, you can see it's right on the x-axis. It's y equals 0. Now, here I have a vertical asymptote at x equals 3, right? And it looks like there is a horizontal asymptote at y equals what? 2. Okay, a word of caution. In your book, the horizontal and vertical asymptote, for the horizontal asymptote, the book says f of x equals 0, f of x equals 2. That is not mathematically correct, right? And actually, that's what it said behind this here. So I graded out and I put this on top so we write our own, all right? So, you know, just remember that. Okay. All right, let's go ahead and graph these. And yes, these are going to be without a calculator, all right? Yeah.
On the first page, in the second problem where the horizontal asymptote equals 0, because there is no x in the numerator, how is it always just 0 if there's only an x in the denominator, or vice versa?
Yeah.
Okay.
You just have to compare the degrees. If it's,
but there's no x.
Where is there no x?
In the numerator.
Where? Which one?
In the second problem.
Here? Right, but what's the degree in the top? 0, and here 2. So again, higher degree in the denominator means y equals 0. You have to compare degrees with degrees. The degree here is 0. Okay. All right, so here we go. To graph the function, you have to find everything we just talked about. So first, let's find the 0. For that, you just say x plus 2 equal to 0. X equals -2. So we have a 0 at -2 comma 0. Okay. Vertical asymptote. We have to set the denominator equal to 0. X equals 1. And that kind of tells you that you're on the right track, right? Because if you graph x equals 1, it's a line that crosses x equals 1. That has to be vertical. So yes, it's a vertical asymptote. All right? Now, for the horizontal asymptote, I have to compare the degree in the top, the degree in the bottom. They're both the same. So I have to take a ratio of the coefficients. 1x over 1x is 1 over 1. So y equals 1. Okay, so let's put what we have in there so far. So I have y equals 1. I have x equals 1. Ooh. I have -2 comma 0 as my 0. One other thing I would like for you guys to find is the y-intercept, okay? So the y-intercept is when x equals 0, correct? So to find that, we say let x equals 0. That means we have y equals 0 plus 2, 0 minus 1. Okay, so just plug in 0 for x. So y equals negative 2, which is at 0 comma negative 2. Okay, when you do that, you automatically have your second point here. Do you see that? So now we know that this graph is going to come in, all right, following that asymptote, hit that 0, hit that y-intercept, and follow the vertical asymptote there, okay? It can't go any other place because it's got to follow those asymptotes. Now, the way these rational functions work is like those like video games. You know, when like in some video games when the character exits the screen, like to the left, they re-enter from the right, right? It's kind of like that. So you have the vertical asymptote that separates, you know, left side from right side. So if this graph exits the screen on the bottom to the left of the vertical asymptote, it re-enters from the top here. All right? So when it does that, it, you know, it's going to follow that way. So why don't we plug in a point there? Let's plug in x equals 2. So I get 4 over 1, 4. All right, so it's going to look like that. And, you know, you can also plug in another point, 3. What do you get? 5 over 2? No. Yeah. Right? Which is 2.5. Is that right? Okay? Yeah. So when the graph exits from the bottom to the left of the asymptote, it re-enters on the opposite side from the top. So it goes here and it goes there. You just know that one arm of it is going to be here and the other one is going to be over there, because there are going to be some cases where they might be on the same side. Well, these I already had, and then here, yeah, I kind of chose randomly. Yeah, okay? Okay, and so we know the domain is all real numbers except what? X can equal 1, and then the range is all real numbers except y equals 1. Okay, so let's go ahead and graph this one. Okay, before we move on, one thing about horizontal asymptotes and vertical asymptotes. When you have a vertical asymptote, that is a solid wall. Please stop what you're doing and listen to me for a minute. When you have a vertical asymptote, the graph can never cross the vertical asymptote because that's a point where the graph is undefined, so it does not work. Okay. However, okay, if you have a horizontal asymptote, that's not necessarily the case. If you have a horizontal asymptote, the horizontal asymptotes mathematically only take effect at the infinities, at the far right and the far left. So here, you know, the graph will follow the asymptote, but it's very possible that it can cross the asymptote a million times and then level off again. Okay? The only place where the horizontal asymptote takes effect is at the infinities. So it's very possible for it to cross a horizontal asymptote. Okay? All right. So keeping that in mind, let's do this one. Let's find the zeros. X minus 1 equals 0. So x equals 1. So it's 1 comma 0. The vertical asymptote, we say x squared equal to 0, which means x equals 0. Okay, so technically like x squared is x times x, right? So x equals 0, it's the same. Horizontal asymptote. Compare the numerator's degree and the denominator's degree. Higher degree on the bottom means horizontal asymptote is what? 0. Okay. Why don't we take, let's see what the y-intercept will be. Oh. So if, can we do that? No, right? Because it'll be, right. So no y-intercept. All right, because, I mean, we already know that because there is a vertical asymptote there. Yep. Oh, maybe I won't write in green anymore. Okay. All right, so there is a vertical asymptote and a horizontal asymptote here. And then here. Okay. No y-intercept. 1 comma, okay, so look. At 1 comma 0, there is a 0. But we just said that's okay, right? Because it can cross the x-axis. Okay, so now, okay, let's put in some points here. All right, so I'm going to look at -2 and -1. So when x equals -2, what do we get? It's -3/4. Okay? And when x equals -1, I get -2/1. -2. So here, it's going to be -3/4. And then, oops, here. And then -1. All right? So now take a look. This comes down here. Yeah. Okay, so now look. Okay. This one has a little bit of a plot twist. Remember how I told you when it exits off from the bottom, it re-enters from the top? Except, you see this horizontal, you see this vertical asymptote of x equals 0? Where did it come from? It came from here, right? Okay. When you have x squared equals 0, that's technically x times x equals 0, right? So it's x equals 0, x equals 0. We call that a double root, right? When it repeats an even number of times like that, there is a plot twist. It switches and it stays on the same side, okay? So I'm just giving you a little bit of background, but when you plug points in, you'll already know that. But just know what happens so you won't be like thrown off. So now why don't we plug in, okay, so we already have x equals 1. Why don't we plug in x equals 2? When you plug in x equals 2, you get 1/4 here. When you plug in x equals 3, you get 2/9. Is that higher or lower than 1/4? Lower. So look, it goes back down. And then when I plug in 4, I get 3/16, which is even smaller. All right? So take a look at how this looks. Like this, goes up a little bit, and then it curves back down. Isn't that cool? Look at that. Would you ever have guessed that you would have been able to graph that without a calculator? I mean, how cool is that? Okay, yes. Well, I was just explaining that. That's what I meant. That's what I meant, right? Because this is a double here. If there were 3 x's, it would have alternated again. Only when it's a double repetition. Yes. Yeah, this is for the vertical asymptote. I know you are, because this is literally your second time graphing these, right? When, so it's okay to be confused, right? I've done millions. You've done 2. Right. But that's okay because you don't really need to know that. I'm just saying don't let it like throw you like for a loop that everything alternated but this one didn't. Just know that, like that can happen. Right. Exactly. Right.
Like, I wouldn't know if I'm like,
So let's do more. Let's do more. We gotta do more to see patterns. Okay. Yes.
so in the evolution of cleanup is that does it level off? Like I know it's zero, but the line is like above versus like how on the left side.
Yes.
of
It
the
levels off above.
asymptote,
It doesn't pass again.
and it will never.
Never, because there are no other zeros.
Okay, so okay.
Okay. So take a look at this one. Now this one looks a little different. Yes.
For that one, what would the domain be?
Oh, the domain would be all real numbers, but x can equal 0.
But that zero does.
X doesn't equal 0.
The asymptote is zero, not
The asymptote here, x doesn't equal 0.
um,
This is y equals 0 here.
Whatever the asymptote is, that's what x can
okay.
be.
Yeah.
So then
Okay.
what would the range be? All real
The
numbers,
range
but
is-
y can't equal zero. So yeah.
Technically, it's all real numbers.
The y thing.
No, it's not all real numbers. No. Stop. The range is not all real numbers. The range is whatever this higher number is, less than that. Okay?
How do we find
Y is less than, you don't have to find it.
Is there a way?
Yes, there is. Yeah. You can do it on the calculator. You can find the maximum on the calculator. Most of this is going to be no calculator. Like this, you should be able to do without a calculator. Yeah, actually, I'll get back to you on that. Yeah. Okay, so let's take a look at this one. Okay. So let's take a look at this one. So 0, the math says to set the numerator equal to 0, but the numerator is just a constant. 5 never equals 0, so there are no zeros. Okay? Now, vertical asymptote. You have x minus 1, x minus 4 equal to 0. Now you've got two of them. X equals 1, x equals 4. And that's okay. Now, horizontal asymptote. Again, here, when you have just a constant, the degree is 0 because it's 5x to the 0, right? So the degree over there is 0. Now, on the bottom, this is factored out, but it's 2 because if this had been multiplied out, x times x, right? If you multiply it out, this will be x squared minus 5x plus 4. Don't multiply it out. But had you multiplied it, this would have been x squared. So the degree would be 2, right? Here the degree is 0. Higher degree on the bottom means y equals 0 for the horizontal asymptote. Okay, let's put in the horizontal asymptote. Let's put in the vertical asymptotes, 1 and 4. 1, 4. Oh boy. Okay, hang on. Now we're going to graph this. So, x and y. Now for the first time, I don't just have 2 regions. I have 1, 2, 3 regions. And we know that the graph never crosses the x-axis. So all of them, each part is either going to be fully above or fully below the asymptote. So let's see how it's going to look. Now we have to be smart about this. We have to pick, points from each of the regions, right? We never did y-intercept. Why don't we do that now? Yeah. 1 1/4. So no, I haven't done it yet. 5/4. Okay, let's see. So y equals 5 over 0 minus 1, 0 minus 4, 5/4. Yeah. So 1 1/4. I don't know. 5/1 times 4. 0 minus 1 is -1. 0 minus 4 is -4. -1. Okay. So, Okay, so I know now. Okay, so take a look. This already gave me an idea of how this looks, right? Because if I have a 0 to the left above the asymptote, the horizontal asymptote, I know that this entire arm is going to be above the asymptote because it can never cross the x-axis, right? So let's plug in some points though. Why don't we plug in a -1? If you plug in a -1, what do I get? 5 over -2 times -5. How much is that? 1/2? Huh? Oh, no. Yeah, no, I was right. Right? It's 1/2, right? Okay, so this side looks like this. Okay, now let's plug in a 2. When you plug in a 2, you get 5 over 2 minus 1 is 1. 2 minus 4 is -3. So -5 over 3. So -1 2/3. Okay? All right. Huh. All right, it's okay. It's fine. All right, it's still the same place. Okay? -2.5. Okay? Where is it? Is it here? Okay. So now, does this cross the x-axis? No. No, it does not cross the x-axis. So listen. We know that this portion here lives below the x-axis, correct? That means it had to have entered the scene over here, yes? And it's going to exit also in that region. So that's going to look like this. Yes. Okay? Do not make it cross the x-axis because you can't find the peak by hand. That's a calculator thing or like calculus. Okay? Now, okay, no. Let me finish this and then I'll take questions. Write down your questions. So now I'm going to the third region to the right. Let me put in a 5. So when I put in a 5, I get 5 over 4 times 1. So that's 5 over 4, 1 1/4. Okay, never crosses the x-axis, so it's got to come down from there and just live over there. Okay, so let's recap. I knew that this graph had no zeros. The y-intercept told me that left arm has to be fully above the asymptote, right? Okay, so I plugged in a second point and I was able to graph it that way. Now coming to the middle section. The middle section could either have looked like that or it could have been at the bottom because it doesn't cross the x-axis, right? And it can't just like come and stop like that. That's not what functions do. So I plugged in this point and then that told me, oh my God, it's at the bottom. So it's got to follow the vertical asymptote to the left. It's got to follow the vertical asymptote to the right. The only way to do that is for it to go up and to go back down. To the rightmost region, is it on the top? Is it on the bottom? I plug in a point. Oh my God, it's over here. And that's the only way for it to look. Okay? All right. Quickly, I don't have too much time for questions. Yes?
You have to plug.
Okay. Oblique asymptotes. So at the very beginning, we said if the degree in the numerator is higher, there is no horizontal asymptote, which is still true. Now, oblique means slanted. If the degree in the numerator is higher by 1 degree, then there is a slanted oblique asymptote, all right? So for this to happen, the degree of the numerator is exactly 1 greater than that of the denominator. So it's like x cubed over x squared, okay? To find the oblique asymptote, you have to divide the polynomial. a little bit of long division over there, okay? I know. The oblique asymptote is then the quotient without its remainder. You're going to divide, throw away the remainder, just take the quotient. Okay, so take a look at this one. This has a vertical asymptote at x equals 1, as you can see. It has an oblique asymptote of y equals x plus 3. And we know how to graph y equals x plus 3. Here's the y-intercept. I go up 1 over 1. Look at that beautifully oblique asymptote. And then the graph follows the vertical asymptote and then the oblique asymptote in both regions. All right? Isn't that like super cool? Isn't it super cool that like the function has like its own like rules and laws to follow, and like it's like regulated by them? Like, it's amazing. Okay, so let's take a look at this one. Okay, 0. X squared equals 0. X equals 0. Okay, vertical asymptote, easy peasy at this point. X equals 2. Horizontal asymptote. Is there a horizontal asymptote? No, so we say none. You don't leave it blank, because so no horizontal asymptote because it's higher on the, okay, but there is an oblique asymptote. To find the oblique asymptote, I have to divide this polynomial. Okay, let's do this. Let's do long division. So x squared, divide that by this, okay, and I'm going to get an x, multiply through, and I get x squared minus 2x. Okay, now I need to add a, plus 0x here for this to work, right? So remember what we did at this point? We change the signs and we add. So I get 2x, right? So now this divided by that plus 2. Okay, so we get 2x minus 4. And then when I subtract this, what do I get? Negative 4. So now I throw away the remainder. I just take this. So the oblique asymptote is y equals x plus 2. Okay. Quickly. Alec. Yes. Okay. No. Okay. Read the directions again. Okay. Let's graph this. So x equals 0 is the 0. Vertical asymptote, x equals 2. Okay. Oblique asymptote, x plus 2. Y equals x plus 2. We know exactly how to graph this, right? You've been graphing it since you were, I don't know, 5. Maybe not. But okay. So let's plug in a point here. Let's plug in. I'm going to be a rebel and start on the right side this time. Let's plug in a 3. When I plug in a 3, I get 9 over what? 1. So that's just 9. So what x equals 3, y is 9. Okay? So take a look. This has to follow, I'm going to extend this a little bit. This has to follow that and then come down and follow this oblique asymptote. Yeah. Huh? Oh, it's not until 10. Yeah, here. Okay. Now, here, do you see how, again, it exits on the top, so it has to re-enter to the left on the bottom? Okay. So here, what happens if we plug in a 1? So it's going to come up, hit this, hit that, and then come back down. Okay, sorry, I do it better this way. It looks amazing, right? But I'm used to graphing from the left-hand side. So yeah. Okay, yes. One other thing. So I'm going to, okay, so again, you have to focus on, right? So regions, always focus on the vertical asymptote. Pick points to the left, pick points to the right, and graph that way. Mind, the zeros and stuff. So now you know why there was a second day to this, right? Okay, the homework for this is the worksheet. And okay, so on the worksheet, I think it should all be okay actually on the worksheets. Okay, all right. So